Direct Delta Mush skinning compression with continuous examples. In this paper, we introduce a compression method that takes a direct Delta Mush model and splits it into two layers. The first layer is a smaller direct Delta Mush model that computes a set of virtual bone transformations. And the second layer is a linear blend skinning model that computes per-vertex transformations from the output of the first layer. The two-layer model can approximate the deformation of the original Delta Mush model with significantly lower costs. The parameters of our model are computed by minimizing the compression error on an uncountable set of example poses. Please refer to our paper for more details of this method. Our proposed model inherits several characteristic effects of direct Delta Mush skinning. In this example, both direct Delta Mush and our model can create skin sliding effects, which are visible at the thighs of the character. Linear blend skinning with sparse skinning weights has local deformation effects, where the transformations at joints cannot propagate very far and the deformation looks rigid. Using denser weights for linear blend skinning produces smoother deformation, but the thighs swing side to side due to the rotation of the hip joint. Here is another example where we can see the skin sliding effects of direct Delta Mush and our model on the body of a character. Again, linear blend skinning with sparse weights has a rigid look, while linear blend skinning with dense weights has smoother deformation. It creates expanding artifacts on the chest. Our model can also preserve the negative bulging effect of the direct Delta Mush skinning, which can be used to set up realistic deformations around the hip joint. In this example, traditional skinning methods, such as linear blend skinning, always create fold-over artifacts regardless of the skinning weight's choice. Next, we show additional results of our method with different number of virtual bones. In these examples, the virtual bones are visualized by the red dots, and the reconstruction errors with respect to the original direct Delta Mush model are visualized by the color map. As we increase the number of virtual bones, our approximations also get better. Next, we show several comparisons to validate our method. In this example, we compare the effect on using different ranges of motions. The result on the left was generated by setting the same rotation range for every joint. The result on the right was generated by computing the rotation ranges from an animation sequence, which helps to improve the virtual bone distribution as well as the reconstruction error. In this example, we compare our model with a linear blend skinning rig using helper joints. Here, we can see some correspondences between our virtual bones and the helper joints, which are set up by a professional artist. Visually speaking, our model offers a similar deformation quality with the helper joint setup. Finally, we show a screen capture of our system running on a GPU. Here, the running time of our skinning model only takes a small fraction of the whole graphics pipeline. Thank you.